Computing and AI for All are pedagogical influences. In building this curriculum, we focused on 5 pedagogical influences. The first one being instructional strategy. In 2018, the National Academies of Sciences published a report that examined the research on K-12 EL's learning, teaching, and assessment in STEM subjects. Amongst the findings discussed in this report were the following 5 promising instructional strategies to support STEM content and language development. Engage students in CS practices. Engage students in meaningful interactions. Use multiple registers and modalities. Leverage students' resources. And focus on how language functions in computer science. The use, modify, create pedagogical approach is followed in each unit to gradually release independent learning to students. First, in every unit, a CS concept is introduced using an engage activity that connects to students' lives and an unplugged activity to motivate students to understand the CS concept while doing a hands-on activity. The students then use the pre-created Scratch project to observe the concept from a user lens and explore the code for the corresponding actions from a coder lens. Next, the students modify the same project to practice coding and increase their understanding of the CS concept. And finally, students create their open-ended, unique project that includes requirements for coding the focal CS concept. The Tip-and-See pedagogy. Tip-and-See is a learning strategy that guides students through an existing Scratch project and teaches them to identify what the project does and how the code makes it work. The Tip-and-See activities are built into each unit and target Scratch-based learning objectives as well as CS conceptual objectives for each unit. The Tip-and-See allows students to view the Scratch project from a user perspective and understand as much as they can, reading the title, instructions, and purpose before running the project. Once they've run the project, they then see inside, look at the code, and examine the different sprites that are in the project, the events that start the scripts for each sprite, and explore how changes to each script will make changes to the project. The third pedagogy is the 5E instructional model pedagogy. This pedagogy reflects the constructivist theory of learning, where students construct knowledge and understand it through experiences. It is an inquiry-based approach that's grounded in active learning as students are engaged in the topic, motivated to learn, and guided towards developing the targeted skills. The 5 phases in the 5E model are engage, explore, explain, elaborate, and evaluate. Each of the 4 units in the CAI for All curriculum guides students through these 5 phases. The engage phase is where the students engage in an unplugged activity and learn about a memorable mentor. In the explore phase, the students complete the Tip-and-See activity, where they explore the project from a user and from a coder point of view to view how the project runs and then understand why the sprites do the actions that they do. In the explain phase, the students create planning pages where they plan out their unique project that they will create to demonstrate the knowledge of the CS concept. In the elaborate phase, the students use the planning pages to build from scratch their unique Scratch project to demonstrate the knowledge that they've learned on this CS concept. And in the evaluate phase, students review each other's projects, complete a reflection journal to identify any struggles that they've had and things that they did to overcome these struggles, and to give positive feedback on fellow classmates' projects in identifying things that they did well and things that could be improved. The evaluate phase also allows students to see what other students have done in order to learn new things that they could do in future projects. The culturally responsible pedagogy. The culturally responsible pedagogy, CRP, is a pedagogical strategy that aims to engage culturally and linguistically diverse students in the classroom and to validate and empower them. There are numerous ways that CRP has been implemented into the classrooms and the curriculum. 5 commonly described aspects of culturally responsive instruction include helping students to value the perspectives of others, affirming a sense of belonging in their community, validating students' cultural identities, educating students about the diversity of the world around them, and supporting students to develop an awareness of the impactful social structures. Research has shown repeatedly that CRP increases the academic success of ethnically diverse communities. As educators strive to broaden the participation of students from underrepresented communities in the field of computer science, we believe that the integration of CRP principles into computational thinking curricular materials, as well as into professional development for teaching those materials, will promote student success and increase interest in the computer science field. Learning activities in our curriculum include cultural content, diverse role models in the computer science field, student reflection, and discussion. 5 W's, English Language Arts Pedagogy. The 5 W's, who, what, when, where, and why, scaffold is used for both reading comprehension and pre-writing in classrooms to identify story elements. We also use this strategy in our curriculum to help students visualize and plan their Scratch stories or projects before coding. Our project planning sheets contain the 5 W's as questions. Who are the sprites, the characters? What will the sprites be doing, the actions or the plot? Where does the project take place, the backdrop or setting? When will the actions take place, the user events? The why question was intentionally left out as research indicated that students did not understand how to implement this into their projects. This approach still encourages and supports individual creativity and flexibility central to the design of Scratch. Why use Scratch? Computational thinking concepts can be introduced at a younger age. Scratch is sufficiently scaffolded for novices to start to program with little or no formal instruction. And Scratch is community-based, which means it was designed to encourage sharing of programs and communication with other programmers.